Alright, so in these problems you are being asked to give the end behavior, the zeros, and to graph the polynomial function. So first off, let's deal with the end behavior. Remember, for end behavior we look at the leading term right here. If the exponent is odd, then you know that the end behaviors are opposite of each other. And when the leading coefficient is positive, then you know that the end behavior on the left side goes down and on the right side goes up. Okay? So in terms of the notation, as x approaches negative infinity, f of x goes to negative infinity. And as x approaches infinity, f of x also approaches infinity. So now we're going to find the zeros. So first thing you look at and see if there's any common factor. And in this case there's a common factor of x, so we're going to factor it out. And so when you do that, you get x squared minus x minus 2. And then you check to see if this quadratic right here has any factors. If it factors, fine, go ahead and do that. So factors of negative 2 that add up to negative 1 are negative 2 and 1. So you get x, negative 2, and positive 1. So then we factored as much as we could. The zeros are, for this one here it's 0, for the next one it's positive 2, and for the third one it's negative 1. Okay? The multiplicity of each of these is 1, because they are factors only one time. So this is one factor, this is 1, the power up here is 1, the power up here is 1. So the multiplicity of all these three is 1. So that means that on the x-axis the graph is going to cross through those values. It's not gonna be tangent. It's not gonna touch and return. Okay? So let's set up for the graph. So the next step would be to plot your zeros. And so here we have 0, 2, and negative 1. Okay? You know that the end behavior on the left side of this point is going to be coming from the bottom. So it's going to be coming up like this. And then it's going to go through the 0. At some point it's going to curve back up and go out through the 2 like that. Okay? Now, we need another point here so that we have a better sense of how the graph is going to curve, how low it's going to go. So I'm going to ask you to find additional points. So the one that makes sense here is x is 1. Pick x equals 1. So you set it up f of 1, which means 1 to the third minus 1 squared minus 2 times 1. You're substituting 1 for all the x's, for every x in the polynomial. So this gives you 1 minus 1 minus 2. So that's going to give you negative 2. So then you know that an additional point is 1, negative 2. So negative 2 is not that negative of a number, not that low. So we can actually do our y-axis just like the x-axis with negative 2 like that. So 1, negative 2, I'm going to plot that point. It's going to go about here. Okay? So now I can connect the points with a smooth curve. And the only thing, if you have access to a graphing calculator or Desmos.com, I would go ahead and plot it on Desmos.com just to confirm your answer, and so that you can get the relative maximum and minimum values. So right now, I'm just going to do, use a different color. I'm just going to graph a curve based on the points that I have here. So it would go something like this. Something like this, and it would curve back up. Oops, I missed the 0 by a little bit. So this would be the function that I would turn in, and you would get credit for this. You'd get full credit for this. Now if you have Desmos.com, this is what it would give you. So when you put the equation into Desmos.com, you would put it in this way, like this, and it gives you the actual graph. And so when you do that, you check it'll give you some gray points when you click on the graph. It gives you some gray points, and when you hover over the gray points with the mouse, it gives you the coordinates of the max and min point. So the relative max point would be negative 0.5, approximately 0.6. So it'd actually be a little bit higher right here maybe. So this curve would have gone just a little bit higher, not that much more, but a little bit higher. And then the relative min would be 1.2 and then negative 2.1. So again, that one looks like I'm pretty much on the money right there. Like it's pretty close. Okay, so then I'm going to do it over in red. So the graph would be like this, through the 0, through the 1, negative 2, then a little bit lower, and then back up like that. So I was pretty much right. The only thing I was off a little bit on was this part. But on a tester quiz, if you turn in like the initial graph that I had, you would get full credit because you gave me the end behaviors, you gave me the zeros, you understood multiplicity, and you added additional, at least one more point, okay, additional to give you a better sense of the curve. This part right here, you would only know if you had access to a graphing calculator or Desmos or some other app that, gives you all those details. All right? All right, so number 2, you look at the end, you need the end behavior, and so again, you look at the leading term right there. It's an even power, so either both ends go up or both ends go down. Because it's a positive coefficient, then we know that both ends of the polynomial of the graph will go up. So then as x goes to negative infinity, f of x goes to infinity, and so does the right side. Okay, they're both infinity. And now we're going to find the zeros. So this one actually has a quadratic structure because I have that power here twice as big as that power right there. It's 3 terms with the last one being a constant. Okay, so I can factor it like I would ax squared plus bx plus c. Like it has that same structure. Okay, so then I look for factors of negative 28 that add up to negative 3. And for that we have negative 7 and positive 4. So x squared minus 7, x squared plus 4. Okay, that's the f of x function. So for the zeros, remember we make this equal to 0 and we solve. And so this one gives me no real zeros. Okay, but this one I could factor further as x plus radical 7 and x minus radical 7. So the 2 zeros here, and they both have multiplicity 1 because the power here is 1 of the factor. So that means that on the x-axis, the graph is going to go through radical 7 and negative radical 7. So the zeros are plus and minus square root of 7. Since I'm going to be graphing these points, I'm going to take a calculator and see what radical 7 equals. And it's approximately, so plus or minus 2.6. Okay, 2 6/10, rounded to the nearest tenth. Another thing that I noticed for this function is that the function is even. So I know that it's going to be symmetric with respect to the y-axis. Okay, so that helps a little bit to know that. So now we're going to set up the graph. Okay, so I've set up, notice I leave the y-axis blank because you don't know how much space you're actually going to need to plot this, so I'm just going to leave that for later. I'm going to plot the 2.6, again, so approximately right here, and negative 2.6 approximately right here. Okay, I noticed the y-intercept is negative 28, so that's already, I know it's, if I were making both axes to scale, same scale, negative 28 would be off the screen, right? So I'm going to condense the y-axis. I'm going to count by a different interval so that I can fit the graph in this space right here. Okay, but before I do that, I need additional points. Notice how my 0 is at 2.6, so I can figure out what f of 1 is and f of 2 is. You always want to look for additional points between your zeros. So I'll pick 2 and 1, and I'll do the work right here below. So f of 1 means 1 to the 4th minus 3, 1 squared minus 28. So that equals negative 2, negative 30. So it's even lower than the y-intercept. F of 2, that's 2 to the 4th minus 3 times 2 squared minus 28. So that gives you 16 minus 12. So that's 4. 4 minus 28, negative 24. So then the graph is going back up. When x is 2, the graph is already on its way up, the curve. So, let me see. I'll count by 5s on the y-axis. So that's, I'll do 5, 10, 20, because I've got to go at least to 30. And leave it like that. Okay. So at 1 I have negative 30. Same color. So at 1 I have negative 30, and I know because the graph is symmetric with the y-axis that at negative 1 I also have negative 30. Okay, so that. Then at 2 I have negative 24, so that would be about here. And so at negative 2 I have negative 24. So again, about here. Okay, and then negative 28 was my y-intercept, so that's about here. So I'm going to plot the graph using the points. So it goes like this, goes through right there, up, and the same, try to make it symmetric with respect to the y-axis. It goes up like that. Okay? So there you have the function. I would go to Desmos.com, and then on that, when you do that, you will notice that the lowest point on the graph, the minimum, is 1, whoops, let me just erase that. So 1.225, and then negative 30.25. So it's very close to the point we got right here, very close, but it's not exactly the same. So there is a lower point than this one right here. There is a lower point, which is this one. And then because you know it's symmetric with respect to the y-axis, you know that negative 1.225 is also on the graph. Okay, so these 2 points right here are your minimums, and you get this on a program such as Desmos. Okay, but by hand, if you're just graphing it by hand, just want to emphasize this, that if you're graphing it by hand, like on a test or quiz, this is what I expect to see. Okay, you're not responsible for these 2 points. So this is enough to get full credit.